objects you can wrap up into a single unit, and an extension includes cast, indexes, functions, and other objects. I have logged into my pgadmin4. I'm going to take a look at the built-in extensions that has come pre-installed with the instance of Postgres database, and also the sample database we loaded has also got an instance of an extension. So I'm just going to expand the databases. We've got two databases listed, so I'll click on the plus sign. We'll take a look at the sample database we loaded, which is this DVD rental. So I just expand that, and you can see we've got one extension, and the extension is a PGSQL. So if I go to the properties, we can see the name, that's the ID, the owner. Let's look at the SQL. This is the SQL basically used to create it. This is the schema it belongs to, PG_catalog. Let's look at the stats. Dependencies, non-dependent. Okay. It's got some dependents here. There is a function that's dependent on that, and we've got these functions all dependent on that. So there is some dependence, but no dependencies. So extensions basically are used to wrap other objects to make it easier to maintain. So we've got one extension here in PGSQL. So let's have a look at the default database that was installed, which is this Postgres. If I expand that, it has two extensions. So let's have a look at what the extensions are. We've got the PGSQL, which we've looked at an instance in the sample database, and we've got one called admin pack. So I'm going to right click and go properties, so we can look at the properties. That's the name, and it tells you what it does. It's for administrative functions for Postgres. So a lot has been wrapped into this admin pack. We can look at the definition. Just tells you the version. Look at the SQL, nothing has changed. If we come here, right click, if you want to create a new extension, you use that with the create command and click on create extension, and that will give you all the options and parameters to add. Again, you can delete or drop a extension. You can cascade, you can create a script from it. So if we wanted to create a script from it, it should also generate a script. So this is a script. I'm just going to bring it down a bit. So you can see this is basically a script that's been used to create this extension called admin pack. So that's it for this lecture on extension. Extensions basically is a concept where you wrap other objects into a single unit, making them much easier to manage. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'll be going through some basic database concepts. We'll begin with the database, what a database is. A database basically is a collection of organized information or data that is stored in a table. A table, on the other hand, stores information in rows and columns. So a table will store usually a collection of related data entries in columns and rows. This table here is similar to what a database table is. So the columns are horizontal. For example, this word terminology can be referred to as a column, and this word meaning can be referred to as a column. The rows these rows are going vertical. So these database, table, columns, all these are referred to as row. So basically this is how the table is structured in a database table. So you've got the columns going horizontal and the rows going vertically. Each row in a database table is referred to as a record. A schema is a collection of database objects. I will show you examples of this later on in the course. So any item is referred to as an object in a database. A database is an object, a table is an object, a view is an object. So these are all objects. So a collection of database objects housed in a container is referred to as a schema. Primary key. A primary key is a unique identifier such as your driving license number or your health insurance record. Is a unique identifier that is used to identify unique records. So no two people can have the same records. So you are able to enforce that using a primary key. A foreign key, on the other hand, is like a primary key, but not exactly. It is used to reference a primary key in another table. For example, if table A has a primary key and table B has a primary key too, so you can have the primary key from table 2 acting as a foreign key in table 1. Likewise, you can have the primary key in table 2 acting as a foreign key in table 1 or vice versa. So a foreign key usually is used to reference another primary key in another table, but primary keys are unique per table. You can't have two primary keys in one table. There are two other concepts I want to illustrate with you. We've got the relational database. A relational database is a database with related tables. Also, we've got the concept of relational database management system. It's referred to as RDBMS for short. It is the software that manages the databases. So examples of the relational database management systems are Oracle, Microsoft SQL Server, MySQL. There is a lot more, but I've just restricted my examples to these three. So these are the basic database concepts that you will come across when working with SQL. Hello and welcome to this lecture. In this lecture, you will learn about the data types in Postgres. We're only going to cover the basic data type. And the data types includes the Boolean, which is a Boolean value, character, number, temporal, array, and special types. A Boolean data type can hold one of three possible values. So it can either be true, false, or null. Null meaning there is no value. So when you insert data into a Boolean column, Postgres will convert it into a Boolean value, which could be yes for true, or false, or N for no. So if the value is a 1, it will be a yes or a true. If the value is a 0, it will be a no or a false value. A null value means you don't know what the value is. So null doesn't mean, it just means empty. You don't know it. There are three main types of character data type. So you've got the char, you've got the varchar, and you've got the text. So the char data type basically is a fixed length character with blank padded. So what that means, if you insert a string is a text. If you insert a string that is shorter than the length of the column, Postgres will pad the spaces to make up for the other. The n here refers to the character. So you can have, maybe if you've got 4 characters there, what you're saying is that you want the column to take 4 characters. If you only enter 2 characters out of the 4, Postgres will pad the other spaces to make up the 4 characters. That's what that means. However, if the character is longer than the length you have specified, for example, if I specified 4 characters and I insert or try to insert 5, Postgres will complain because the character limit has been exceeded. The next is the varchar. The varchar, the n here represents the number of characters that you pass in there for it to accept. Varchar basically is a variable length character string, so you can accept strings or text or variable length. You can store up to n number of characters with variable length characters, so you can store any amount with this variable length character. The n value, it's variable, so you can store up to n characters with the variable length character strings. Postgres does not pad any spaces when the stored string is shorter than the length of the column. Unlike the char, if for example I specify 255 characters and you only enter say 10 characters, Postgres does not bother to pad the other spaces as it does with the char type. The next is the text. So the text also is a variable length character and it accepts strings. If you notice, I have not put an n value here because with the text type you don't need to specify the length of the character. So basically, theoretically, a text has an unlimited length of characters, so you can enter an unlimited number of text you want in that field if you wish to. The number data type. Postgres provides 2 distinct type of numbers. The first is integers, and there are 3 types of integers. So you have the small integer, which basically is a 2-byte signed integer, and then you've got the integer itself. This is a 4-byte integer, and then you've got the serial. The serial basically is the same as integer, except that in Postgres it generates and populates values into a column automatically for you. So if you're creating a table, for example, and you have an ID column and you want it to auto populate, you'll have to use the serial data type. The next type of number data type is the floating point number. There are 3 main types of floating point numbers. You've got the float, and the floating point number whose precision at least n represent the number and has up to 8 bytes. The next is the real or float 8. This is a double precision or 8-byte point number. The float can also have up to a maximum of 8 bytes, but it must have at least an n value. Then we have the numeric or numeric PS. This is a real number with P digits and S number, which is, these are precision numbers. So we have the P digits with S numbers after the decimal points. The next type of data type is the temporal data type. This data type stores things like date and time related data. There are 5 main temporal data types in Postgres. So I'll start with the first one, which is a date. The date basically stores date values. And then we have the time that stores time of the day value. We've got the timestamp that stores the date and the time. And then we've got the interval. The interval stores periods of time. And we've got the timestamp. This stores both timestamps and the time zone data. The timestamp is a Postgres extension to the temporal data type. The next data type is the special data type. So besides the primitive data types, Postgres also provides several data types related to the geometric and network. So the first is the box. Basically, this is a rectangular box type of data. And then you've got the line. So some of these are used with geometric or network related. And then you've got the line, which is a set of points. And then you've got point, which is a geometric pair of numbers. And then you've got the one seg, which is a line segment. Then you've got polygon, which is a closed geometric. You've got the init, which is an IP4 address. This is a network related. And then you've got the MAC address, basically refers to the MAC address on a network card. The final data type I'm going to talk about is the arrays data type. An array basically allows you to store an array of strings. You could also store an array of integers and so on. Array basically are multiple variables. So a variable can store one value. An array can store multiple variables as one value. So you can store an array as strings. You can store an array of integers and so on. Just remember that an array contains several variables. Where a variable stores one value, an array can store multiple values as one array. So that is it for this lecture on data types. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres unique constraint to ensure that the value in a column or a group of columns is unique to a table. So there are times where you want to ensure that certain column have unique data across the table. For example, you may want the email addresses to be unique, the username to be unique, or the employee ID to be unique. For example, if you are dealing with social security numbers, you don't want two people to have the same social security numbers and so on. So you ensure that by using unique constraint. Say for example, we're trying to create a table. Normally when you create or you implement unique constraint, it is better to do that at the table creation stage. So when you're creating a table, for example, I'm creating a table called person. These are the columns. And you can see here on that email, I've implemented a unique, I've added unique, which means I want every record in this column to be unique. So you can apply unique constraint to multiple columns within a table. So let me show you how this works by actually creating this table. I've already added a script to my query tool, and I'm going to create a table inside the fruit database, this database here. So this is the script to create a table, and I've added a unique constraint to the email column. So let me go ahead and run the script to create a table. Okay, there's some error. Okay, now I've created a table. What it was, I had other scripts inside this editor, and he was getting confused with which one I was trying to run. So now it has created the table. So now it's time to insert records into the table. So this is the script I've written to insert a record into the table. So I'm just going to highlight it here. So I'm going to insert this record into the table we've just created. These are the columns of the table. This is the name, and that's the email address. The email address is where I've applied the unique constraint. So let me run that. If I run that, it tells me query successful. So I now have a data with someone called this, with these details on the table. So let me quickly do a select statement on the table. I'll do select star from person. All right, so let me just refresh the table list. Okay, so I've got a table called person. So I'm just going to highlight. When you have several scripts in the editor, it's probably best to highlight the script you're trying to use. Sometimes the editor can get confused, even though you've got a semicolon to indicate that the statement ends there. So I'm just going to run this so you can see. So this is our table. It contains one record. It's got John, Doe, and so on. All right, so that's the record for that table. Quick thing I want you to notice, although it's not part of this constraint, is that if you notice here, the primary key for this table, I've given it, it's got data type of serial. So when I was creating the table, when I was doing the insert, I didn't have to automatically add the one number. When you're using the serial data type, it automatically populates this primary key or this integer value. All right, so it's done that for me. Anyway, that's not what this is about. So this is about unique constraint. All right, so I've added one record. So let's assume I want to add a second record. I've now got someone called John. I want to add Jack. Okay, I want to add Jack to the table. Notice I'm going to use the same email address as I've used for J Doe, because they've both got the same initials, haven't they? This guy is John Doe, this guy is Jack Doe. So they've both got same initials, but there's going to be an error because I've implemented a unique constraint. So let me run that. You can see the error. Duplicate key value violates the unique constraint person email key. All right, so it tells you here the email j.doe@bluelime.com already exists. Okay, so that is the constraint working. So it will not allow duplicate entries in a column or duplicate data. So to get around this, I can just change this to 2 and make this j2 dot. Let me insert that, and hopefully that should work. You can see it has not worked. If I do a select on the database, on the table, I should have 2 records in there. I've got a John Doe and a Jack Doe. You can see the email addresses are different because they are now unique. So that's how you implement a unique constraint. Thank you for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I will be introducing you to the WHERE clause. The WHERE clause basically is used to act as a filter to filter rows that are returned from a select statement. Without the WHERE clause in a statement, it can return all the data you have specified. So the where clause acts as a filter to filter out the records that are returned from a select query statement based on certain conditions or criteria you have specified inside the where clause. So let's look at how you write a where clause. So the syntax basically is this. You, after your select statement, after you key in this keyword, you've done your column select if you're selecting specific column. If not, if you're selecting all the column, then you can replace the column names with asterisks. You specify the name of the table and then the where clause. The where clause usually appears after the from. Okay, so you must place it after the table name, which is after the from keyword. Then you place the where clause. Inside the where clause, you specify the conditions that must be met for the returned data from the query. All right, say for example, you can specify that you want to return data from column 1, column 2 from this table where maybe the first name begins with this or certain conditions matches a certain criteria. So the where clause will be acting as a condition. If the condition you specified in the where clause is met, then the relevant data is returned. So let's illustrate how this where clause is used. So I've logged into my pgadmin 4, and these are the tables from this DVD rental database, the sample database here. And I'm just going to pick a table to work on. I've got a table here called customer. So let me quickly right click on this table and go to the properties so we can see the properties of the table. So this should reveal things like the columns of the table. So if I click here now, we can see these are all the columns of the table. So let me run a quick query on the table. I'm just going to right click and go query tool. I'll wait for the query tool to launch, and then I'll write a very quick select statement. So I'm going to do select star from customer, which is this table here. And that should, if I execute this, that will give me, it will return all the data. You can see 599 rows retrieved. All right. So say for example, I don't want all this data retrieved. It has received 599 rows. And if I don't want all 599 rows returned, I can apply a filter. Okay. And the filter will reduce the amount of records returned. At the moment, it has returned 599 rows. You can see here saying 599. So I want to apply a filter here. So to do that, I'm going to get rid of this semicolon there and type in the where clause. So this is a where clause that will act as a filter. Then I need to specify the condition for the where clause. So I'm going to say where the store underscore ID. Notice here we've got store ID 1, some of them are store ID 2. So I'm going to say where the store ID is equals to 2. I've now applied a filter. So the data that's going to be returned from this query should be less than 599 records, because I'm using this filter here to restrict it. So I only want to return data that matches the store ID number 2. Anywhere where the store ID is 2, those are the data I want returned. So notice I've used an equals to here. Equals to is known as a comparison operator. So that's what we use to compare. Okay, so if I run this now, just watch out, it should return less than 599. So let me execute that. Look out here, it says 273 rows retrieved. So we've been able to filter the rows that have been returned using this query here. So the where clause here acts as a filter, and you can specify any condition inside the where clause. So whatever condition you specify in the where clause, when the query is executed, it will compare that condition, and based on the condition you've specified, it will return the data that matches that criteria. So that's how you use a where clause to act as a filter. Thanks for watching, and bye for now. The where clause is also important when you are deleting records. So you can use the where clause to act as a filter so you don't delete all the records from a table. Inside the where clause, you can specify what you want to delete or what you want to update. Very important, the where clause. Bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to query data from all the columns within a table. To query data from a table is quite easy if you want to query all the data. The syntax you use is this, very basic and simple. You just type in the select keyword followed by the asterisk symbol. The asterisk symbol basically means retrieve all the columns and all the rows from a table. You need to specify from keyword, which indicates where you're getting the data from. So let's go ahead and do that. Let's log into our PG admin tool. So go to all programs. If you're on the Windows, click on the Postgres folder and click on PG admin 4. If you're on a Mac, look for the PG admin 4 icon and click to launch. Once it launches, we need to connect to the database and then begin writing the query. Once it launches, click on the plus sign on the left here to expand the server. It tells you you've only got the one server. Click on the plus sign here and you should get a prompt to sign in. So enter your password. This will be the password set during the Postgres installation. Ooh, looks like I've got mine wrong. Let me try again. Okay, this time it tells you server connected on the bottom there. So let me expand the databases. The database we are going to use for this lecture is the sample DVD rental database, this one here. So I'm going to click on the plus sign. If I click on the plus sign, it should tell me here database connected on the bottom right. So I'm connected to the database. You can see the dashboard here. I need to expand the schema. We've only got the one schema, which is public. So I'll click on the plus sign and that should reveal all the objects within that database. So the tables, this is what I'm interested in. Let's expand the tables. So these are all the tables for this sample database here, and I'm going to go for the customers table this time. So I want to query all the data from this table. Before I do that, I just want to check the properties of the table. I'm just going to right click on the table and go properties, and it's trying to retrieve data from the server. Let's give it a few minutes to do that. Okay, so it tells us here, name of the table is customer, the owner of the table is Postgres, schema is public, the table space where it stores this data is PG_default. So let's check the columns here. We can see these are all the columns of the table, and I want to retrieve data from all this column. I'm not going to be specific of which column I want the data from. I want the data from all the columns. So I want all the columns and all the records. So I'm just going to click exit. Next thing I want to do is access the query tool. So I'm going to right click on this table here called customer and click on query tool, and that will launch the tool I can use to write the query. So give it a few minutes. We now have our query tool here. I'm just going to drag that. The output will be displayed in this area here. So to build the query, you type in select. SQL is case insensitive, so you can write select in lowercase if you wish. It doesn't really matter. So I'll do select followed by the asterisk. Asterisk indicates that I want everything, all the columns, all the records from the columns and rows. And then I specify the name of the table. I like to write the keywords in capitals so that they stand out. And if you notice also, the keywords are also colored, makes them stand out. So from is where I'll specify the name of the table, which is customer, and then a semicolon. Semicolon is important, always good in case you have several statements inside the editor window. The semicolon indicates the end of one statement, so it's a good practice to always end your statements with a semicolon. So what this query is saying basically is get all the records from the customers table. This asterisk means retrieve all records from all columns. So let's execute that by clicking on this lightning bolt here, and it's trying to do that, and it tells you here 599 rows retrieved. So this is everything from this table called customers. All right, so you can see all the columns on top, and these are all the records, okay, from this table. It's 669 it says. Okay, so we've got everything, all the data that's ever been saved into this table. We have captured it using this simple statement. So basically, this is how you use the select statement to retrieve data from a column. If you use it with the select and the star, it gets every data from the table and displays it in the output. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to query data from specific columns within a database table. The syntax we are going to use is this. Basically, we use the select keyword followed by the column names, and then we select the name of the table and enter it into the from field. So this here is the structure of how we would write a select statement to query data from specific columns within a table. We are going to be querying data from our sample database, which is the DVD rental sample database. So let's go ahead and open up our admin tool and begin. So let's launch our admin tool. Go to your start, all programs. If you're on a Windows, if you're on a Mac, look for the Postgres folder and make sure you click to open the pgadmin 4 and give that a few minutes to launch, and then we can try and connect to the Postgres server and access the database. So give it a few minutes, it should load. Once it loads, you need to expand the server option within the browser here. Click the plus, and once you expand, you need to click on this, and you should have a prompt that you have to enter your password. So click on the plus sign, it will give you this prompt here. So enter the password. The password will be the password you would have set during the Postgres installation. So just enter that password in there. Once you've entered it, click OK. And you should now, it tells you server connected just on the bottom. So once you're connected to the server, you have access to all the databases and the objects. So I'm going to expand this databases option here. It says we have 2 databases. So we'll give it time to expand. The database we're going to interrogate or query is this sample database here called DVD rental. So click on the plus sign to expand the database objects. All right, so it tells you here database connected. So we need to expand the schema area and expand the public schema and get access to one thing that is good practice is before you query data from a table, it's always good to check the table structure. So these are the tables for the DVD rental here, and the table we are going to query for this lecture is going to be, let's just pick a table. I'm going to query this table here called city. So I want to check the structure first so that I see how many columns it's got and so on. So I'm going to right click on the city here table and go properties. So when the property page opens up, it gives me the name of the table. It's called city. Tells me who owns the table. It's owned by this user here. The schema is public. Table space is this. So let's check the columns. This table has 4 columns. This is the data. These are the data types. So we've got city ID, city, country ID, and last update. So what I'd be interested in from this table is the city column and the country ID. So I want the city and the country ID. So those are the 2 columns I want to query data from this table. So let me begin by writing the query for that. So I'm going to right click on this city here and click on the query tool. And that will give me the editor where I can write my query. So this is where I'm going to write my query. So I've already decided that there are 2 columns I need. I need the city. Let me expand these columns here so we can see them. So I need the city column and the country ID. So this is how I would specify the select query. To select, SQL is case insensitive, so you can make it uppercase or lowercase, it will still work. So I'll just select the columns. So the first column will be city, comma, followed by country ID. Country underscore ID. And then the next will be the from. From will be the name of the table is called city. And this is basically the select statement completed. So I'm querying data from specific columns here. The columns from this city table here is the city, which is this column here, and the country ID, which is this one. Rather than get all the data, I only want specific columns. And I've ended the statement with a semicolon. Notice the keywords here are highlighted, so you know that they are keywords, the select and the from. Now I'm going to execute the query and the output should show here. So click on this, that looks like a lightning bolt, or you can press F5 and it should execute the query. And so this is how it tells you total query runtime 600 rows retrieve. So this is basically the city and this is the country ID. All right, it tells you here, it shows the data type and the Yeah, it shows you the data type and then the name of the columns. So that's the city here. This, for example, this is a city called Abu Dhabi, and the country ID is got 101. And if I scroll down, we can just pick another country. We've got Dallas here. We've got 103. City, these are all cities. And then these are the country IDs. So basically, this is how you retrieve specific data from a table by selecting specific columns, and then you query the data from those columns. So that's it for this lecture. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to remove duplicate records using the distinct keyword. There may be times where a select statement may return several or multiple duplicate records, and you may want to reduce the duplicates. And the way you achieve that is by including the distinct keyword in your select statement. Let's have a look at the syntax to create a distinct statement. So this is what you do basically. You include the keyword distinct inside your select statement, followed by the column names you want to apply the distinct to. And obviously you still have to use the from to indicate the tables coming from. You can order the data after the distinct has been applied, and you can order by either in ascending order or descending order. So let's have a look at how this works. So log into your pgadmin4. I've already logged in, and once you've logged in, select the DVD rental database. Just click on the plus sign to expand the database objects, and it should tell you the database is connected. Expand the schema and click on the public schema. Let's expand the tables. So these are all the tables for that sample database, 15 of them in total. Before we go ahead and remove the duplicates, I want to run a quick query that will show the duplicate entries. So the table I'm going to go for here is this table called inventory. So if I click on the plus sign, you can see all the columns from that table. There's only 1, 2, 3, 4. The column I am interested in is this column here called film ID. So right click on the name of the table and go query tool. It will launch the query editor. So I'm going to write just a very simple select statement, and I'm going to select just one column here, which is this film ID column. So I'm going to select film ID, film underscore ID. From the table name is called inventory, and a semicolon to end the statement. So now let me execute by clicking on this icon here that looks like a lightning bolt. If I click on that, it will output the query. So you can see all these duplicates here. These are all duplicate entries. You can see 1, 1, 1, 2. So there's a lot of duplicate entries. You see several 4s and so on. So this is what I want to get rid of. And the way I do that is to add a distinct keyword to the select statement. So I just come here and type in distinct. Oh, I got it wrong. Just remove the I, remove the, that's it. You can see the color has changed as well because it's a keyword. If I now execute this query, these duplicates will be gone. It will only show me one instance of each. All right, so I'll execute that again, and you should see that the duplicates are gone. What I want to do also is add, I want to order it. So I include an order by, I'm going to order by the film ID, and I'm going to order it in ascending order, that is from A to Z. If I run this again, it will filter the data. You can see now the data has been returned and it's filtered, and there's no duplicates. You can see I've got 1, 2, 3, 4 and so on, but the duplicate entries have been removed. So that's basically how you use the distinct keyword to get rid of duplicate records in a table. So that's it for this lecture. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to sort data returned by a select statement. So we are going to use the order by clause inside our select statement to activate the sorting of the data returned. This is what the syntax will look like. So the format basically will start with a select keyword. We will select specific columns from a table and then apply the order by clause in order to sort the data returned from the select query. So let's launch our pgadmin4 tool by going to all programs. If you're on the Windows, click on the Postgres folder and then pgadmin4. If you're on a Mac, also locate the pgadmin4 icon and click to launch the icon. Once the tool launches, let's connect to the server by clicking on the server plus here, and then if you click on the Postgres server, it should give you an option to log in. So click on the plus sign and we just need to enter the password. So the password will be the password set during the installation of Postgres. So I'm connected. It tells you here server connected on the bottom right. So let's access the database. We have two databases here. The database we are going to run this query on is the DVD rental database. So I'm going to expand that. It tells you here database connected. So let me expand the schema and then the public schema. And let's look for the table. And these are the tables for that database. We got 15 tables, and the table I'm going to query here is the country table. I'll go for the customer. Sorry. I'm going to query the customers table. So if I expand that, you can see all the columns from this customer table. Let me just expand this a bit so you can see. So these are all the columns from the customer table. I'm going to select specific columns here. I'm going to select the first name and the last name column only. So let me open the query window by right clicking on the table name and clicking on query tool. That will launch the query editor from where we can build the query. So this is a query editor. The query will be outputted in this area here. I'm just going to drag that down a bit to create some more room. All right, so let's write the query here. The query I'm going to write will be a select. I'll start with the first name column. Always specify the column the way it's been defined. So I'm going to do first name underscore name. You use a comma to separate the column names, and then I've got the last name here, and I'll type in last underscore name, and then I'll specify the from. Always good to write your keywords in capitals to make them stand out. The editor here also gives them a specific color to make them stand out. So in the from field is where you specify the name of the table, which is customer. And that is basically it. I'm not going to include an order by yet. The reason being, I want to execute this query so you can see the difference when the data is sorted and when the data is not sorted. So I'm going to click on this icon here to execute. As you can see, this is the output from the query here. The data is not sorted in any way. You can see here the first name here. You got say Jared, you see Linda, you got Elizabeth, you've got Dorothy. So the data is not it's not ordered in a way. So it is returned the way the data was entered into the table. So we can change that by adding an order by clause. So the way it is now, without using an order by clause, it sorts it in ascending order. So now I want to be specific and apply an order by clause. So to do that, when you are adding an order by to your statement to filter data, it's usually the last thing you add to the statement. So I'm just going to add an order by. I do order by. I'm going to order by the last name column here. So you can order by first name or last name. It doesn't really matter, but I'm going to order by last name. So I'll do last name. Underscore name. And then I want it in a descending order. When you use the order by, you have to specify how you're ordering the data that is returned by the select statement, either in a descending order or ascending. This is the current structure here of the output. You can see Ellie, Smith. There's no order here. You can see the A appears here, Anderson, and you can see J there. So by the time we run this query again, after adding the order by, this last name will be structured in the way it is sorted. You'll see a more structured ordering of this column here. So keep an eye on this column here. All right, so let's execute the query again. And we just see, as you can see, we've ordered the data in a descending order. That is from Z to A, if you will. You can see here, it displays young first, Y, and then if I scroll down, you can see, you probably see if there's any A, it will be right at the bottom. Let's scroll down. You can see these are the A's because of the way I have ordered the data. All right, so if you're ordering in descending order, it will take the format of Z to A. If you're ordering in ascending order, it will be from A to Z. So if I change this, for example, from descending to ascending and run this again, it should change the structure. You can see now the ordering is different. Is from ascending means A to Z. You can see that now A appears first and so on. So that's how you sort data returned by a select statement. So if you don't specify the order by, the default is ascending. So when you are ascending, it sorts the data from A to Z. If you're using descending, it sorts the return data from Z to A. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I will be introducing you to the Postgres order by clause. When you query data from a table, Postgres normally returns the rows in the order that the data were inserted into the table. In order to sort the result set, you use the order by clause inside the select statement. So basically, the order by clause allows you to sort the rows returned from a select statement, and it does this in ascending or a descending order based on the criteria you have specified. So the main purpose of the order by clause is to sort the data that has been returned from a select statement, and you can specify